What if I told you there's a universal speed limit written into the very fabric of reality? A speed so fast, it defines how cause becomes effect, how stars shine, how you see this very video. And yet, some say there might be something faster. Today, we call it the speed of light. But what if it's more than just a number? What if it's a clue, a riddle, hinting at secrets buried deep in the code of reality itself? Light speed, 299,792,458 meters per second. That's nearly 300,000 kilometers every second. In the blink of an eye, light could have circled the Earth 7 times, and still have time left over. But how do we even know how fast light travels? It wasn't always obvious that light had a speed at all. For centuries, philosophers like Aristotle believed light moved instantaneously. No speed, just presence. That changed in the 1670s thanks to a Danish astronomer named Ole Rømer. While observing Jupiter's moon Io, he noticed that the moon's eclipses appeared delayed when Earth was moving away from Jupiter, and arrived earlier when Earth was approaching. He realized it wasn't the moon that was late. It was the light taking longer to reach us. From this, he made the first real estimate of light's speed, around 220,000 kilometers per second. Not perfect, but astonishingly close. Then came Armand Fizeau in 1849. He built a device with a rapidly spinning toothed wheel and a mirror placed several kilometers away. He shone light through the gaps in the wheel, and if the wheel spun fast enough, the returning light would be blocked by a tooth. By adjusting the speed, he calculated the time it took light to make a round trip, giving him a more precise value. But the most precise measurements came in the 20th century, when Einstein's theory of relativity revealed that the speed of light isn't just fast, it's constant. No matter how fast you're moving, light always hits you at the same speed. And in 1983, we stopped measuring the speed of light, and instead, redefined the meter based on it. Light speed isn't just a number we measured. It's now the ruler we use to measure everything else. So why is this speed the limit? Why can't we just go faster? Einstein's Special Relativity tells us that the faster you move, the more massive you become. At light speed, your mass would shoot to infinity. And to push something with infinite mass, you'd need infinite energy. That's not just impractical, it's impossible under the laws we know. Imagine a race where every step forward triples the weight on your back. At first you run, then you jog, then crawl. Eventually you can't move at all. Not because you're tired, but because the universe won't let you. But here's a riddle. What if something didn't need to accelerate to light speed? Because it was always faster? Enter the tachyon, a theoretical particle that never slows below the speed of light. It doesn't just break the rules, it plays a different game altogether. It moves so quickly that time for it flows backward. It could arrive before it departs. Send a message today and receive the reply yesterday. In a universe where cause and effect are sacred, tachyons are heretics. And yet, mathematically, they don't violate the laws. They just live beyond their reach. No one's ever detected a tachyon. Maybe they don't exist. Or maybe they exist in a place we can't touch, like shadows cast from a higher dimension. And then, there's quantum entanglement, the phenomenon Einstein famously called spooky action at a distance. It's not magic, it's not teleportation, but it hints at a universe where the threads of reality are more tightly woven than we ever imagined. But we humans, we dream. We imagine engines that ride the curves of space-time like waves in an ocean. The Alcubierre drive. It doesn't accelerate through space, it warps it. Space expands behind the ship and contracts in front, moving the bubble without ever breaking the light barrier. It's like asking reality to bend its own rules, to let us slip through the cracks in its logic. So, what if this speed limit isn't a wall but a mirror? A boundary not meant to stop us, but to show us where we've come from, and how much more there is to learn. Throughout history, every time we reached a limit, sound, gravity, the edge of the map, we broke through. And each time, we found a universe bigger and stranger than we imagined. Maybe this is no different, or maybe this one's here for a reason, a cosmic safeguard, a law etched into the bones of reality. So the next time you feel the sun on your face or see the stars blink across the night sky, remember, that light has traveled millions, even billions of years, just to meet your eyes. It's not just light, it's time, it's truth. It's the fastest messenger the universe allows. At least, for now. But maybe we're still asking the wrong question. What if the speed of light isn't a limit for us, but for something else? A universal firewall, not to keep us in, but to keep something out? Some physicists whisper of a hidden layer beneath reality, what they call the prion soup, or the sub-quantum foam, a realm where light is slow and causality is optional. What lives there? What rules it? There are hints, glitches in cosmic background radiation, tiny asymmetries in quantum spin, moments where equations hesitate, not fail, just flicker, like a signal struggling through static. And what if, just what if, light isn't the fastest thing at all? Maybe the real frontier isn't out there in the stars, but beneath what we already think we know, beneath speed, beneath time, a layer we weren't meant to see. At least, not yet. If the universe is hiding secrets, maybe they're waiting for the right eyes to notice, the right minds to ask the next impossible question. So, what do you think is faster than light? Drop it in the comments. Who knows which idea might someday be right? And if you want to keep chasing the next cosmic mystery, the next crack in the rules, maybe, don't disappear just yet. There's more coming. Keep watching the stars.